I'm Joanne Gallagher, host of the Think Future podcast. This week we're talking with David Clark of Positive Zero and author of What Colour is Your Building? Join us in a minute for the conversation with David, who shares his vision for zero carbon precincts and how to best tackle energy consumption and optimise efficiency in buildings. This podcast is brought to you by Arcons, a global leader pioneering solutions and services to the AEC and manufacturing industries to support digital transformation for the built environment and smart manufacturing. Visit arcons.net to learn more about how Arcons are helping organisations design, build and solve through digitalisation. From Arcons to you, welcome to our Think Future podcast series. Each week we'll share conversations with industry leaders from around the world to find out how they're thinking future. Subscribe to Arcons Think Future for access to more episodes, interviews and profiles. David Clark of Positive Zero is a chartered structural and building services engineer with over 30 years design experience in Australia and the UK. His work on building projects and corporate strategy has won numerous sustainability awards. Positive Zero was established in 2022 by David to deliver sustainability strategy, technical solutions and knowledge sharing in the Australian property sector. He has recently written an industry guidance on the electrification of buildings and precincts in Australia. Welcome to the programme, David.
Thank you very much for having me, Joanne.
David, can you walk us through the highlights of your career as an engineer at Mott MacDonald in the UK to becoming an independent consultant as director of Positive Zero?
Well, I graduated from uni in the UK in 1990 as a structural engineer, as a civil engineer, and that's where I started my career as a structural engineer with Mott MacDonald in Sheffield in the UK. I then got a secondment to Melbourne to work with Conall Wagner, who are now Oricon, for 2 years and ended up staying for 14. And sort of during that time, I started to get more and more interested in building services engineering and how buildings worked. So I was still a structural engineer, but I was getting more and more involved in that multidisciplinary aspect. Then when I left Oricon or Conall Wagner and joined Sinclair Knight Mertz, who are now Jacobs, everyone keeps changing names, I was there as to lead the structures team in Melbourne, but I very quickly got interested in sustainability and through sustainable concrete and embodied carbon of concrete. So this is back in about 2001, and that sort of really opened my eyes to an area that I'd previously not been exposed to. So I set up the sustainable buildings team, and at that point I stopped really doing pure structural engineering, but carried on doing building services and multidisciplinary engineering. And then it was around that time I was looking at Australia, and there was no rating tools at that point. The Green Building Council of Australia hadn't been formed, and I thought it might be useful to have a rating tool. So I rang the building research establishment in the UK and said, is anyone developing an Australian version of BREEAM? And they went, no. And I went, well, could I do that? So I signed a memorandum of understanding with them and started developing this tool that we sort of called OzBREEAM, and I was working on that on and off for a little bit. Then the Green Building Council was formed. They wanted a rating tool, and I said, well, here's one I prepared earlier. And so that then it went through a process where I worked with the Green Building Council to convert that into what is now called Green Star. But that's why Green Star, the structure of Green Star was more like BREEAM than it was the US rating tool, which is LEED, because everyone just assumed the Australians would take LEED and just do an Australian version of LEED. As it was a sort of hybrid of the two. So that was sort of my involvement. So then 2003, that got released. I ran the first 5 or 6 accredited professional training courses. And then after that, I joined Cundall as a partner in Melbourne and helped set up that business. Moved back to Manchester for about 6 years with Cundall, then moved back to Sydney for another. I've been in Sydney now for over 9 years, most of that time with Cundall, but I set up my own practice in 2022. And while I was back in the UK, I wrote a book on the carbon and energy footprint of buildings that looked at energy consumption, embodied carbon, and transport. So that's a sort of brief snapshot of what I've done. And in that time, I've worked on lots and lots of different projects, been involved in various industry committees. I've chaired the Green Building Council's technical advisory group for the last 9 years. Yeah, now out on my own, doing my own thing, working with lots of different private sector and government sector clients.
It's quite an amazing story, that. You're like the grandfather of Green Star in Australia.
Well, probably one of the key people that was involved in it in the early days, and consider myself really fortunate to have now been involved in it again sort of 10, 15 years later, to give it, like, it's gone through a huge transformation over the last 3 or 4 years, and been really proud to have been involved and worked with the GBCA and all the myriad of committees and industry people that have been involved in taking the old tool and bringing it up to date for the challenges that we have now, which are quite different to what they were in 2003 when we sort of started on this journey.
So you mentioned that book. Is that the book called What Colour is Your Building?
It is, yeah. So I decided to write that when I was in the UK. It originally started as what was going to be a little paper, and it just kept getting bigger and bigger, and then eventually became a book. So that was published by Reba Publishing, and yeah, there was quite a bit of research went into that, looking to try and debunk a few myths and to identify areas that really needed much more focus. So looking at embodied carbon, also looking at real energy consumption as opposed to sort of modelled consumption. And in the UK at that time, all the energy modelling it wasn't like Neighbours in Australia, which is based on real energy consumption and metered energy consumption. It was all sort of theoretical and building code. So people were missing lots of the total energy consumption of the building. So this was trying to put all that into context to say, how do you benchmark energy and embodied carbon? And then that's great. Now, what do you do about it? So here are the 10 steps to reducing the energy consumption of buildings, and here are the steps you can take to reduce the embodied carbon of buildings. And obviously now embodied carbon's become quite a big topic in Australia. If I was writing the book again, the one area that I really missed was the electrification of buildings. So back in sort of 2013, it was the focus was on sort of energy consumption, and I think that revolution in renewable energy that you've seen around the world, particularly in wind power and solar power, I don't think anyone had really envisaged how fast that was going to move, and also therefore the importance of getting gas out of buildings. So it wasn't really a thing back then, so that was the bit I missed in the book. The rest of it I think holds up pretty well. So probably to atone for that, I've been writing electrification guides. So I wrote the electrification guides for new buildings and existing buildings for the Green Building Council that came out the year before last, and currently putting the finishing touches to an electrification guide for new precincts, which will be released in March this year. And then done various other guidance and work in electrification. So yeah, I'm trying to make up for the what I missed in the book.
Well, it's more relevant now to talk about electrification than it was then. So, but the book does talk about debunking myths and some misunderstandings as a basic fundamental understanding of the whole running buildings efficiently. Can you speak to some of those myths and debunk them?
Well, I think it's interesting. In Australia, a lot of the focus on energy has been driven by things like Neighbours. I don't think people understand quite how important Neighbours has been in driving that. Actually, I've been around long enough to know that when it was first discussed, it was going to be called ABERS, So it was the Australian Building Environmental Rating System. And then by the time we had the next industry workshop, it changed to neighbours, because everybody needs good neighbours, of course. So that's why they changed it. But that tool has been really transformative because it's based on the metered energy consumption. So you can't hide from what your energy meter's saying. Whereas energy modelling, you can sort of make a model say whatever you really want it to. And if you ask 5 people to model the same building, you'll get 5 different answers. Whereas the neighbours was about what's the actual consumption, and then working back from that, writing the energy protocol, so you are predicting the actual consumption. So if you do the modelling, at the end of the day, you're going to find out whether you were right or not, because it's going to be verified with real information. And in the UK, they've only just adopted neighbours. Up until 2 or 3 years ago, nobody was really looking at the real energy consumption of buildings. It's a bit of a problem. So I think that's great, because that then drives better decision making, because you can then go and validate whether it works or not. And I suppose the challenge with something like embodied carbon, which is all based on modelling, is that you don't have that validation at the end of the day. There isn't a meter to read that tells you what the embodied carbon is. So that's a challenge in how you benchmark the embodied carbon. So it's an issue we have to address, but how to benchmark that and rate it is a little bit more challenging. But I know the neighbours team are looking at that at the moment to come up with a neighbours version for embodied carbon. But the big driver to reduce embodied carbon is not as much in the design as in the supply chain, because you still need to build the building. No matter how you design it, it's still going to have concrete, steel. Even if it's a timber building, it'll have concrete and steel in it somewhere, and all these other materials. And so there's only so much you can do to design out carbon before it's, can I buy a low carbon version of that product? So that's where the main game in embodied carbon for me is getting the supply chain to decarbonize their products, so that you can buy low carbon products. But if you don't ask for low carbon products, then people don't necessarily produce them. So you need the design and the construction industry to drive the demand, and then supply chain, the manufacturers can then provide those products. So that's, I think, a big area of focus. I know the Green Building Council is really focused on that at the moment, and that's one of the key shifts in the Green Star tool from the previous version, is to really put the emphasis on embodied carbon and the supply chain, rather than just doing lots of modelling.
What's the name of that new tool they've developed?
It's the RPV, so there's a responsible products value, and that's based on other third-party certifications. So the Green Building Council is not going to certify a product, but they're going to recognise other third-party certifications, and from those third-party certifications you get a score. So if you had 3 carbon certifications, they don't count all 3 because then you'd just be double counting the same thing. So that's still being developed, but I think that's going to be quite transformative in the industry when that database is available, so that people can just go and see the products and go, well, these are the low carbon versions of those products, or the products that have got social and environmental certifications. So there's quite a bit going on at the moment, but probably the electrification and the embodied carbon are, well, everything begins with E. Electrification, electric vehicles, and embodied carbon are probably the 3 key things from a sort of carbon energy perspective. There's lots of other environmental and social issues, but those would be the 3 big ones for me from a carbon and energy perspective.
And are there any big myths associated with those 3 that you'd like to speak about?
Well, there's always lots of myths and misinformation out there. Where to start? I suppose if we look at electrification, you always hear it can't be done, it's going to be too expensive, there's not enough space, I can't put it in my existing building, but these are all technical challenges that can be relatively easily addressed. There's always a solution. If somebody said, "Oh, you have to get gas out of your building, or else," you would find a way to get gas out of the building. I think the first step in this journey is not putting gas in any new buildings. So ultimately, we've got to get gas out of existing buildings, but the first step is, well, let's not make the problem worse by putting it in new buildings. The main reason for doing it is cost. Is, the gas prices are not going to go down. Look at who's advocating for keeping gas in buildings. It's the gas companies, which is fairly obvious. But what they never talk about when they're saying about, let's say we're going to have green gas, which is like a biogas. It's made from agricultural waste. So we're going to have this green gas, and it's coming. And then you go, well, how much of it, and when, and what's it going to cost? Go past the headlines, and at best, Australia could probably generate 5% of its current natural gas supply from biogas, because there's only so much agricultural waste, and all that waste is spread around. It's not necessarily near a gas pipe. So how do you get the gas then from where the waste is into the gas network? So the argument for green gas is just to perpetuate and prolong the use of natural gas. It doesn't stack up. And if you did want to use green gas, it's more energy efficient to turn that gas at source into electricity, to put it into the electricity grid, to then use that electricity in the building, put it into a heat pump, convert it into heat. That is still a more efficient and energy efficient process than taking the gas, trying to get it from wherever you've generated it through all the pipes to a building and then burning it in a gas boiler, because gas boilers are not going to get any more efficient.
So maybe there's different technologies at different parts of the system, depending on what you're doing. But for living in buildings,
we absolutely don't need gas in buildings. We don't need gas to heat our water. We don't need gas to heat our spaces. We don't need gas to heat our food. These are all low-grade heat applications, and the technologies that we need to go all electric already exist. That there are products available that do everything that you need now to go all electric. And then as soon as you go all electric, you can then use renewable electricity. There's no 100% renewable gas available today, and there almost certainly never will be, because you can't produce enough of it. And then people say, oh, well, what about green hydrogen? Can't we just use green hydrogen in our buildings? And that's a really inefficient process, because green hydrogen is produced from renewable electricity. So if you generate a lot of renewable electricity and you use it in a building and you put it into a heat pump will typically produce 3 times the amount of heat to the electricity you put in. So for every kilowatt hour of electricity you put in, you get 3 kilowatts of heat out. For every kilowatt hour of gas you put into a gas boiler, you get about 0.8 kilowatt hours out. So heat pumps are inherently much more efficient than using gas. So if you look at green hydrogen, you've got to make the hydrogen using renewable electricity to break down water and turn it into hydrogen. You've then got to get that hydrogen and compress it, somehow get it to your building. Then you need in the building to have hydrogen appliances. So you'd have to change the pipes and the equipment anyway. And then you burn that, you combust that hydrogen to produce heat. If you use the same renewable electricity you needed to produce that hydrogen, you get 4.5 times the same amount of heat. So from an energy efficiency perspective, it's a waste of electricity to turn it into hydrogen to put into buildings. Is there a role for hydrogen in the Australian economy? Absolutely. And I think in those heavy industries which need high intensity heat, there'll be a role for hydrogen there. Having said that, a lot of steel is already made in electric arc furnaces. So if you've got scrap steel, that uses electricity to create steel. It's in the blast furnaces where the bigger challenge is. And in terms of other industrial applications, there are lots and lots of new types of heat pump technology that either exist or are being developed to generate heat, up to 250 degrees C, which is a very significant proportion of the industrial heat application. So there are going to be electric solutions for a lot of the things that people are saying we need gas for. And at the moment you need gas, but the future's changing.
So David, if you were a developer of a new precinct, what would you be thinking about, or what do you need to think about in terms of design?
Okay, well, there's quite a few things to consider here, because the precinct is like it's the interface between the electricity grid and the buildings. So it's the thing that sticks lots of buildings together before they get connected to the electricity grid. And so in terms of a new precinct, the first thing is don't put any gas pipes in, full stop. Just leave the gas out, and therefore all buildings will be all electric using heat pumps, induction cooktops, and various other technologies as required. You also need to then think about electric vehicle charging. So you've got to design your electrical infrastructure now to meet a few changing circumstances. So the first one is you need your electrical infrastructure to provide your heating and hot water and cooking. Your electricity infrastructure is already there. You just maybe have to make it slightly bigger to cover electric vehicle charging. Heating and cooling obviously depends what state you're in Australia. In some parts, the predominant energy demand is cooling, so the heating's not going to make that any worse, and in other places it will be different. So the electrification of buildings is pretty easy when you're designing a new precinct. Where it's changing is the electricity grid that is supplying that precinct is also changing. And we're moving away from coal and gas powered stations to a lot more renewables. And they are much more variable in load, particularly solar. Solar is clearly just daytime electricity. And when the sun goes down at night, the wholesale electricity prices go shooting upwards, because all this solar energy that's been generated suddenly drops off. There's still lots of wind at that point, and there's various other things. There'll be battery storage, there'll be grid scale batteries which are already under construction. But I think what's really important in the design of buildings and the precincts is the buildings need to work flexibly with the grid and respond to the generation of electricity in the grid. And you'll do that so you can save yourself lots of money, because in the middle of the day, electricity, there's so much rooftop solar in Australia, there's so much solar electricity being generated. If it's your own roof, then the electricity's free. But even if it's coming from the grid, the wholesale price of electricity in the grid goes negative during the day. For large portions of the year, in most states, the electricity price is negative, which means if you're generating electricity as a wholesale generator, so you have to pay somebody to take that electricity off your hands. And then the price goes shooting back up again, and you make that money back and then some. So the way in the past it used to be that power stations just sat there and just kept chugging away, and electricity was cheaper at night because you were generating the electricity and people didn't need it as much, so it was cheaper. So that's why you ended up with peak and shoulder and off-peak tariffs. Well, that's sort of changing, because we'll have less electricity generated at night than we will in the day because of solar. So then you go, well, how do we use the energy how can we store energy during the day so that we can use it in that early peak when everybody goes home, turns their air conditioning on, puts the kettle on, turns the telly on. That's when you get a spike in demand. So that's where making buildings more interactive with the grid and responsive to the grid is, I think, where the big game changer is. And that'll be a few methods you can do. I mean, one of the simple things, and people that have their own solar panels already do this, is you put your washing machine on during the day so it can just run when you're getting cheap electricity. But you can't shift everything to the day. So we then start looking at energy storage. And energy storage could be just simple things like hot water tanks. Generate your hot water during the day, use it at night. You're not using any electricity. And then you start getting into batteries, which price of batteries are coming down, price of electricity. The difference between the price of electricity in the day and at night is going to start widening, and then batteries are suddenly going to become cost effective. A bit of a challenge at the moment, but I don't think we're very far off before, if you can afford to put a battery in, it will pay for itself in a few years. We're not at that stage yet. But what's also coming is electric vehicles, and they have huge batteries. And so the plugging your car in at your home and it's sitting there and it charging up when the electricity is really cheap, and then feeding back into your home at night when the electricity price is expensive. Well, you just use the cheap electricity you've stored to run your home at night. So I think that's something that people haven't wrapped their heads around. We're so used to just parking a petrol or diesel vehicle outside and it just sitting there. It's doing nothing. Whereas an electric vehicle will become part of the energy system in your house that will save you money.
We'll be back to the conversation in just a minute. In the meantime, here's a little more about Arcons. Arcons has a mission to advance the efficiency, quality and profitability of project outcomes for its customers by providing best-in-class technology and services. Are you looking for a digitalization and sustainability-focused partner to help you achieve your goals? Join the thousands of AEC and manufacturing customers globally who have turned to Arcons to start their journey toward a better built environment and smarter manufacturing. With more than 50 locations around the world, Arcons can connect you to the right technologies and expertise so you can improve your competitive position and increase profitability. Arcons has an industry expert to help you navigate the best pathway forward wherever you are on your digitalization and sustainability journey. Visit arcons.net to find out more. So you hear people say, well, you're getting fossil fuel out of the ground, and you're also getting the minerals for the metals for the batteries and all the solar panels out of the ground, and the population is increasing and people are wanting cars, and so there's more and more demand for lithium, for example.
There is, yes, and I think having mining that is done sustainably, because whatever we do, we're going to be mining something out of the ground. Because we just build and consume stuff, and there's a whole argument to say we should be building and consuming less. But whether it's lithium, if you're having a petrol car, you've still got a lot of materials going into that vehicle anyway. But the interface of EVs and buildings is a real shift, and the misconception about, do we have enough? We won't be able to power. There's not enough electricity in the grid to power all this stuff. I think that's absolute nonsense, because that just assumes that we're going to buy all these electric vehicles, electrify all the buildings, and not change the electricity grid. Well, that's not going to happen. The electricity grid is changing now. It's going more and more renewables. At the same time, we're seeing the increase in growth of electric vehicles. We'll start electrifying buildings. All these things are going together and are happening at the same time. And these things will all work together. Electric vehicles will be charged in buildings, not at petrol stations. because most of the time your car is sitting at your home doing nothing, or it's sitting at work doing nothing. So while it's sitting there, connect it to the grid and make it part of that system to help manage the peaks and troughs. And then buildings will work together with the electricity grid to help manage the load. So instead of the old days where you just have a whole bunch of power stations at the end of the line and it just floods the electricity and you just can do whatever you like and not have to worry about it, the shift now is that electricity has been generated everywhere. It's been generated in homes, it's been generated on buildings, it's been generated, in lots and lots of different places rather than concentrated in a few power stations. And the storage of energy is also going to be distributed. There'll be grid scale batteries, which are typically going where the old power stations were, because that's where all the electrical infrastructure already is. So it's the cheapest place to put them. But we're going to see batteries everywhere, not just in buildings, in precincts, and in vehicles. So it's just a time of change, but it's going to be, it feels like it's a radical change, but this can't happen overnight because you don't just change the car fleet overnight and you don't just change every building overnight. But what we need is a plan over the next 10 years to really just drive that transition, build up that capacity in the industry, build up the skills, build up the companies that can do this, and make sure that we don't leave people behind, that it's not just those that can afford everything that can get all the best electrical equipment, and the people that can't afford it are left with gas. Because as we transition away from gas, the people that are left on gas will be paying more and more for the maintenance of the gas infrastructure because it needs maintaining, and we don't want gas leaks. So there's a risk there, and that needs to be managed, and that's where government has a role as well, to make sure that this is an orderly transition that takes everybody with us, doesn't leave people behind. It's all doable.
Yeah, you're talking about behavioral change. We've had a whole shift in the way we work now and how we use buildings. Could you speak a bit to the pre and post pandemic behavior of people working and living in buildings, and how we can change our mindset and behavior around those buildings and how they're used?
Well, I think that's a really good point, because if you'd said at the beginning of 2020, everyone can work from home, we can do all this remote working, we're going to have this flexibility in how people work, and not everybody can work from home, but if you'd said that was all possible, the HR people wouldn't allow it, it was very difficult to do that, it just wouldn't work, then we were forced to do it. It wasn't let's try this. It was, we have to do it. And now the whole work environment has fundamentally changed in the space of 6 months. And then people say, but we can't change the way that we design buildings and the way that we, run buildings. We have to do it the way we've always done it. And you go, no, you were there in 2020. If we have to change, we can change. So, yeah, I think working from home, I now work from home, but I was already spending quite a bit of time working from home, the same as everyone else. When I go into offices in the city, you see that there are vast swathes of empty desks, and that's a real challenge for commercial landlords at the moment. But that's also changed the energy patterns, because you still got to run the buildings even if there's only 2 or 3 people in them, and then at the same time you're using more energy consumption at home, because instead of closing the door and the air conditioning's on, so the air conditioning's on at home and it's on at work, even though you're only in one of those places. So be interesting to see what has happened to energy consumption around the world as a result of that. I haven't seen any statistics on that, But again, I suppose it all plays back into this building's energy load and flexibility. Is we need buildings to be flexible in their energy use at home, and we need buildings to be flexible in their energy use at work, and there'll be opportunities to do that. If you're working from home, then you've got less transport, so you're not getting the transport emissions. So I suppose it's a case of just looking at it all together and seeing, well, what's the net emissions as a result of people working from home versus at work.
Can we talk about price and how it can be used as a lever to affect change?
Yeah, to do anything, you need to spend money. So if you want to affect change, unless it's a behavioral change that doesn't cost anything, usually there's an investment needed, and you're saying invest in this and it will give you a return later. The challenge is sometimes you don't have the money to invest, even if you know you'll get your money back in over 2 or 3 years. If you haven't got that money up front, how can you invest? So I think this is where you can't just leave it to market forces to drive everything. This is where government needs to get involved, and there's various ways that could be done, and there's pros and cons with all of them. And I know people have tried different types of incentives, but we're not going to get rid of all the gas boilers in existing buildings without some sort of assistance in a lot of cases. And I think the biggest nut to crack is residential apartments where the hot water systems are owned by the strata. Because now it's not just one person making a decision. You've got to persuade all the people on your strata committee to make an investment to change the hot water system. That is I think if you can solve that problem, everything else is just going to be a walk in the park, because you're now trying to persuade people who own apartments but don't rent them out, that don't see any of the benefit, going, why should I spend this money? I'm not paying the bills. And there's always been that sort of challenge with investing in energy. But so I think you can't just say you can't just use a business case to always drive the change. I think government needs to be involved in how do you help strata and others make that step forward when it's not, they either don't have the money or they don't have the direct incentive. And look, most of the time, what drives change is dollars. If it doesn't make sense financially, it usually doesn't last. I gave up long ago on the altruism of developers being the change for sustainability. You've got to put the business case to them. And if you don't, how do you make your building more attractive to tenants? You go and get a environmental rating, you get a green star rating, you get a good neighbors rating, and you say, we've got a really nice building and we can prove it compared to next door because we've got independent certification. So the driver to get the green star is still a financial driver. Getting gas out of buildings is going to de-risk your building. It's going to make the asset more valuable. Legislation is coming, so at some point you're going to have to take it out. And gas prices are only ever going to keep going up. Every time there's a war, gas prices go up. Every time there's an international sort of supply chain issue, gas prices go up. There's so much profit being made in the fossil fuel industry. It's been driven by money. So that's going to be passed on to the consumers. We see the gas going up. As far as I'm aware, nobody owns the sun and nobody owns the wind at the moment. So there's a good, if you can harness either of those, your fuel supply is zero. You don't have to pay for any fuel. You just need to capture that free energy resource, turn it into electricity, and off you go. So, that's why solar and wind is so much cheaper than coal and gas, because nobody owns it.
Well, David, you're obviously very passionate about this topic. Before I ask you one final question, is there anything more you want to add as we're coming to the end of our conversation today?
I think just don't be afraid of the change. I mean, the opportunity is there. It all makes sense. We have all the technologies we already need. When you go, well, I can buy a heat pump tomorrow, I can sign a renewable electricity contract today. Yeah, everything we need is already here, and it's only going to get more efficient and cheaper as it gets rolled out at scale. So we just crack on and do it. And if you hear people going, oh, it can't be done, just dig a little bit and find out why they're saying it can't be done. And somewhere, usually at the bottom of all that, is a fossil fuel lobbyist or a fossil fuel company or some politician that's looking for a job in the fossil fuel industry after they retire from politics.
When you think future, David, about zero carbon precincts and grids, what excites you the most then? Say if everything you've talked about was applied, how do you see the future?
Well, I think if you move into a precinct where all the vehicles are electric, it's quieter, it's cleaner, it's way, way lower energy bills. Your energy bills are going to go down, the air pollution is going to go down, there's no gas polluting the inside of your house. What's not to like?
What's not to like, indeed. Well, we've very much liked having you on the show, David. So thank you for coming and sharing all of that. And your guidance, would you like to just say where that can be found?
Yeah, all the stuff that I've produced over the years, I have links to it on my website. So I have a library on my Positive Zero website where you can download the book for free, and it's got links to the various guides and other things that I've written over the years. So is that
www.positivezero.com?
.au.
Okay.
Yeah.
Thank you so much, David.
Great. Thanks, Joanna. No, it's been a pleasure talking to you.
This podcast was brought to you by Arcons. Arcons is leading the digital transformation of the AEC and manufacturing industries by providing best-in-class technology solutions from world-leading partners and their own in-house development software from the Arcons Be Smart portfolio for building, infrastructure and manufacturing. Arcons is a company that cares about creating and building a better world. Together, we are working with industry and environmental experts, providing forums and platforms through our Arcons Think community to create conversations that matter to our future generations. We invite you to join in the conversation and participate in our Think community, so like and subscribe to Think Future to stay up to date with the latest innovations and conversations as we advance the digital journey for AEC and manufacturing around the world. You can download our podcasts at arcons.net or from your favorite podcast platform. From Arcons Think Future, thanks for listening.